Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Neighboring bitwise XOR, Leetcode 2683. In this problem, we are given a zero-indexed array derived with length n and is derived by computing the bitwise XOR of adjacent values in a binary array original of length n. A binary array is an array containing only of zeros and ones. Specifically, for each index I in the range 0 to n-1 inclusive, if I is n-1, then the value at ith index in derived is equal to XOR between values at ith and 0th index in the original array. That is, derived value at the last index is equal to XOR between last and first element in the original array. Otherwise, the value in derived at ith index is equal to XOR between values in original at ith and I plus 1th index. Given an array derived, our task is to determine whether there exists a valid binary array original that could have formed derived, and we should return true if such an array exists or false otherwise. Then in example 1, for the given derived array, a valid original array can be 0, 1, 0. So now if we perform the XOR between 0 and 1, we will get 1. 1 XOR 0 will give us 1 and 0 XOR 0 will give us 0. So for the given derived array, there exists an original array for which derived can be formed. So we will return true in this case. But in example 3, for the given derived array, there exists no original array that gives us derived. Now in terms of solution, since we know that original array contain only binary numbers, a naive approach can be to generate all possible original arrays by choosing either 0 or 1 for each position and then check if any of these can form the derived array. For example, consider the derived array 110, then we can generate these 8 possible original arrays and check if any of the original arrays results in the derived array. However, the time complexity to generate these original arrays is O of 2 to the power of n, where n is number of elements in the derived array. Because we generate 2 to the power of n original arrays, and then we have to check if any of the original arrays can generate the derived array by running the simulation that takes another O of n time. So the overall time complexity will be O of 2 to the power of n into n, which is super high. And now the question is, how can we do better? And for that, let's look at the derived array a bit closely. Suppose our original array has elements like A0, A1 all the way up to an-1. Then our derived array will look like this, where at 0th index we XOR between A0 and A1, at first index we XOR between A1 and A2, and so on. And now if you observe closely, all the elements from the original appear twice in a cyclical way. So if we XOR these values, they will cancel out, resulting in zeros. Therefore, if XOR of all values in derived is 0, a valid original array exists. Otherwise, it does not. Now your question can be, why do these elements cancel out? For that, let's have a quick review of the XOR operation. When we XOR 2 bits, the result is 1 if the bits are different and 0 if the bits are the same. For example, 0 XOR 0 is equal to 0, 1 XOR 1 is equal to 0, 0 XOR 1 is equal to 1, and 1 XOR 0 is equal to 1 as well. Additionally, we know that XOR of a number with itself is 0. The reason this holds true is that at a bit level, XORing a number with itself cancels out all the set bits, resulting in 0. So now our approach will be to XOR all the elements in a derived array and check if the result is 0. For example, for the given derived array, XOR values will be 1 XOR 1 XOR 0, which is equal to 0. So because XOR of all values in derived is 0, a valid original array will exist. Hence, we will return true. Now the time complexity reduces to O of n because we go through each element in the derived array only once, and in terms of space complexity, it will be O of 1 because we are using some variables here and there. Now let's quickly jump into the code part. First, let's initialize our initial XOR value to 0, and note that initial value of 0 is a safe choice because x XOR 0 is equal to x. Since at the binary level, 0 has all the bits equal to 0, hence all the bits in the x will remain unchanged. Now we will iterate through each number in the derived array and perform the bitwise XOR operation between it and cumulative value XOR, and in the end we will return true if the XOR value is 0 and false otherwise. Now let's submit this code. Cool. An additional approach can be derived from the current one by noting that if XOR of all values in derived is 0, it means number of ones in derived occur an even number of times, This is because 1 XOR 1 is equal to 0 and 0 XOR 0 is equal to 0. So if the Boolean array derived has an even number of ones or its sum is divisible by 2, then the original array exists. So instead of using XOR here, we can use sum and sum up all the numbers here, and in the end check if sum is even. Now let's submit this code. Cool. And the time and space complexity of this approach is similar to previous approach. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.